I've started the recording. Is my voice audible to everyone? All right, great. So, hi Sarvna, hi Sanjay, hello Jairam, hi Anandita, hi Joshi, hello Ravikant, hello Vidya. All right, so let's jump in. Great. So, today we are going to discuss a very important topic, which is kind of we have included it recently, and it has been quite successful as well. So, all right. So we are going to discuss something called Apache Spark. Apache Spark is a fast and general engine for large scale data processing. When you have to process large scale data, it's fairly fast. So it competes with MapReduce. It doesn't compete with Hadoop per se. It doesn't compete with Yarn. It competes with MapReduce. Okay. The The basic difference between Apache Spark and MapReduce is that Apache Spark utilizes the memory as much as it can, while MapReduce tries to do everything, mostly things in the disk. And that was one of the reasons why Hadoop's MapReduce was designed uh, was slower and was batch wise. So the difference is in the psychology, the way we have built Spark. I mean, few researchers at UC Berkeley have built Spark. All right. Now, it's really faster than MapReduce. It's 100 times faster than MapReduce in memory and 10 times faster on the disk. Now, it builds on a similar paradigm as MapReduce, and it's well integrated with Hadoop and other ecosystems. All right. Now, the ecosystem which Spark has built is really, really strong and powerful. So, Spark remains purely as a computational engine. It doesn't it doesn't provide any kind of storage. It does not provide you any kind of database. Okay, it just remains as a engine which analyzes data. Now, it is not only built for it's not only built for Hadoop, it works with other systems as well. So in this diagram, I'll try to explain what is it. So Spark Core is the main engine which runs things, okay, which runs paradigm, certain paradigm like transformation and action. The way Hadoop's MapReduce provides you map and reduce, in the similar way, Spark at the basic level provides you those things. Now, Spark does not only restrict itself to standalone mode. Okay, Spark can run on top of Yarn, Amazon EC2, or if you have no cluster manager as of today, then you can install Spark on all of your node by using standalone method. Also, Spark can run on top of Mesos. All right. So Mesos, EC2, Yarn, these are the resource manager, meaning these you can think of these three things as operating systems which run your programs in a cluster. So EC2, Yarn, and Mesos you can think of as a distributed operating system to which you give the program and they run. So you write your logic in the paradigm provided by Spark, and then Spark runs the individual execution units using the cluster managers. And cluster managers are many, which are a few of them is Mesos, EC2, Yarn. And in case you do not have any cluster manager and you are starting afresh, then you can install Spark's standalone version on all the machines, mark the machines mark one of the machine as master and rest of the machines as slave, and then you from the master you can run the things, run the code or run the executors or workers on all the slaves. That's a standalone mode. Now that's how Spark get executed. All right. Next is Spark can read the data from all kinds of sources such as HDFS, HBase, and Hive as well. Also, there is another disk, another thing called Tachyon, another kind of similar to HDFS. Okay, there is one Tachyon data source. Now, and many more as in S3 and uh, I mean all kinds of formats and um, all kinds of formats and all kinds of file systems and all kinds of operating systems. It can read data from many more sources. Okay, so Spark can run on any of the clusters which you already have in your organization, and Spark can read the data from any of these data sources. All right. Now, what can Spark do? Spark can do. Spark either can run your code which you will write. It provides you a paradigm under which you will write your program. The way a database provides you SQL, similarly, Spark provides you certain basic construct under which you can do the execution of your code. It provides you have to write you have to first load the data and then you do the operations using Spark. All right. Now, if you are not a programmer, you are not a developer, you can use Spark's SQL. If you are looking for real-time data processing, then you can use Spark's streaming. Okay. If you are a machine learning expert or data scientist, you can run your algorithm or you can build your algorithm using ML library. MLlib is a library which provides you the basic algorithms which are required for machine learning, along with the library libraries such as that performs matrix multiplication, Fourier transformation, and all kinds of libraries inbuilt in the MLlib. And it provides you a way to 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 evaluate the graph. So a graph, if you want to do the analysis of graph, you can use the GraphX library. GraphX is not GraphX is not a database. Okay, GraphX is just a library which helps you load and evaluate humongous graph, a graph such as that of Facebook, Facebook friends, Facebook, the people connections. So if you have to do that kind of analysis, you can use GraphX. And then you have Spark R. Spark R makes it possible to run the R code on Spark. So Spark R provides you this compatibility layer which converts the R code into Spark and then run it. And that does lot of wonders. Okay, now we will jump into how exactly Spark is able to do so many things. So Spark R is basically helping us convert our traditional logic into distributed logic. Okay, that has been one of the biggest contribution of Spark. All right. So it's already installed on hadoop1.nobigdata.com. You can just log in there and then start working on it. All right. Otherwise, if you just want to try it out on your machine, you can download the standalone version and then unzip it, and all you have to do is afterwards run either Spark Shell or run PySpark, either of those. Okay, these are command line versions, interactive versions of Spark. So we will be using PySpark, which provides us interactive Python command prompt on which we can execute all the Spark commands. Okay, now in the similar fashion, it provides you an Scala interactive prompt. Also, it provides you a way to submit your full program onto the cluster. Okay, so let's jump in. All right, is the font visible to everyone? Can you see my screen? All right, great. Let's just log into Hadoop 17. Your account is Hadoop 17, right? Hadoop 17. All right. So here we are. So we have logged in. In this, there is a folder, not here. So let me in. Okay. So you can actually do user lib spark bin PySpark. All right. Yes. So you can see that it's a version 1.5.0 of Spark. It's the latest version and it's good. Although the 1.5.1 is released just a couple of hours back. So, all right. So Spark is being heavily developed, but it is fairly stable as well. So there is no doubt about not learning Spark. So what exactly is this prompt? This is our Python prompt. Okay, this is a Python interactive prompt in which we can write our Python code. For example, we can use this as normal Python interactive system. All right. Also, we can define a function. This is say func, and whatever I'm passing to this func, it's returning double of that. Okay, let's say. So if I now call this function with 3, it will give me 6. So we just defined quickly a function in Python which returns double of whatever is passed. Alright, I hope nobody will have the problem in understanding this kind of code. So we just defined a function, okay? And the important part here is this tab space. You must make sure that there should be a tab space in case of Python. All right. Rest of the construct of Python is just like C and very simple. Okay. Let's jump in then. All right. Now the basic concept around which Spark is built is resilience distributed dataset. Any database, any system which computes data or any system which is about managing huge data, the idea revolves around executing code near the data or executing code on the data rather than the way we have traditionally studied, that we have this middle layer which brings the data from database, does some churning and saves the data back. No, in case of Spark or in case of R or in case of any other system, the idea is to launch your code on the data. So always when we say please execute this code, we always say on what data. All right, so that is the idea, and here that data form is generalized. So Spark's basic concept is resilience distributed data set. Whatever data you want to operate upon, first you load that data and convert the data into resilience distributed data set. A resilience distributed data set is this wonderful thing which is basically a mapping between input data and these machines. Okay, so a resilience distributed data set, you can always imagine that it's an array provided by Spark to you, and this array is distributed. Okay, this big array which looks like a continuous array to you, it is distributed across the cluster. First 10 elements on one, second 10 elements on second, third 10 element on third, and fourth 10 element on maybe on fourth machine, something of that sort. If you have 40 element in RDD, that could be one scenario. All right, so here you can see that this resilience distributed data set has got four sections: first section, second section, third section, fourth section. Maybe there are 10 elements in first, to 10 elements in second, 10 elements in third, or maybe 5 elements in last. Okay, that means that this is an RDD containing 35 elements. Okay, now such an RDD can be operated upon in various manner, and you can load the data onto this RDD either from HDFS, from S3, from normal file system, or from Tachyon, or from any other file system, or maybe from Hive, or maybe from HBase. You can load the data from anywhere onto this RDD. This RDD, whenever you load the data, it just makes a note of which data is where. And this RDD makes sure that when it's executing the code, it executes the code near the data. All right. So that is the duty of the RDD, to make sure to run the code on that machine where is the actual data located. And to you, it will give you a feeling that this is you know a in-memory array. Also, you can convert an in-memory array into an RDD very easily. So an RDD can be persisted in memory so that multiple processes or multiple tasks can use or reuse this RDD. It will act like a cache. Okay, just like the way you persist the cache into memory, similarly you can keep the RDD in the memory. RDD can auto recover from node failures. If one node fails, then RDD will be recomputed on another node in the same way it was computed earlier. Okay, it can have it is basically a huge array in which each element can be of any kind. It doesn't enforce that all elements have to be of the same data type. Okay, just that as Spark has evolved, there are new kinds of RDDs that have come up. For example, key value RDD, meaning each element in this array is of key value, and when you can execute those functions which are very specific to key value kind of data types. Also, it the RDD supports two classes of functions. One is called transformation and other is called an action. Okay, each element in RDD is across the cluster is run through map function. For example, this we'll go through this sentence again, the last one. All right, all right. So let's try to load this data. You remember our word count problem where we had this data like Hadoop 1, no big data you here. So let's try to load the same data, just that the data has been moved into this folder now, data/mr. Okay, so we are saying here, please note here, when we started this, it says that Spark context is available as SC and Hive context is available as SQL context. Okay, meaning your gateway to Spark is SC. So we are telling SC dot text file, meaning sc spark context, please load our text file, and when you are done with loading, assign the RDD which you create in two lines. So basically, it will create an RDD representing this particular file, and then we can do the operation on this RDD. So with just now we have created an RDD called lines. It says it's a map partition RDD. All right. So lines is a map partition. Now this is another example of creating an RDD. Here we are converting this array into an RDD. We are saying sc.parallelize in this array, and this is our array. Okay, now you can see. So this kind of array is also an RDD. It's a parallel collection. Earlier was map partition collection. That's the internal details. All right. Now we can do the operations on these RDD. If you want to see what is there inside lines, we can say take 10, and it will give us this nice array of 10 elements. You see the 10 elements array? Okay, it's basically an array of strings. Each element is a string and load it from that text file which we have specified in text file. All right. Similarly, we can say on my array dot take 4. It'll give us the 4 elements 1, 3, 5, 6. Okay. So the text file has created an RDD. RDD is a remote data structure which is loaded on multiple machines, and using take we brought the data back. All right. Now there are three questions. Let me address those questions. All right. First question is from Sanjay, and there is another question from Savana. All right. Yeah. Okay, I'll address these questions first before moving ahead. So we need to know Python for Spark. So if you want to do the basic programming just the way you needed to know Java or Python for MapReduce, in the same way, you can either get your work done in Python, Scala, and Java. All right. Out of these, the most supported languages are Scala and Java. There are 1% functions or 0.1% functions which are not there in Python yet, but it is on the way. Okay. It is on the way, and also the important part is, as I had expected, that now everybody is moving to Python from Scala and Java because of the rich analytics library available in Python, such as pandas. Okay, so because of very rich library available in Python already, it is actually worth using Python on Spark. Okay, so I will still stick to Python for many reasons. One, it's very easy to use. Second, it has its own really rich libraries if you want to do some local computation along with getting things done on Spark. All right. Now, again, the question from Savana is, which is powerful, Python or Scala? So this question called powerful is very subjective and open to arguments. And so when I say powerful means multiple things. One, does one programming language provides constructs which are better than other one, or does one programming language provide a richer library than the other one? Okay, So whatever is possible in Scala is also possible in Python and vice versa. Just that Scala has been designed from bottom up to keep the parallel computing in mind or distributed computing in mind. All right. But Python has got wide variety of library. Also, Python syntax is something which people find it easy to learn. Okay. Now, lots of people can argue about, let me just save it first, about the languages. So I will keep myself away from the discussion about comparing the languages. Right. Now, question again is but MapReduce also does the same thing. Yes, but in batch-wise fashion. Batch-wise fashion. I will let me just take one more step. Is it there? Okay, not there. All right. So if you remember our problem in the first session where we were having multiple phases of MapReduce, right? Voting problem, for example. So the way it was happening, we had the data in HDFS. It got picked up by MapReduce. Let's say MapReduce 1. Then the data went back to HDFS again, and then we had to do the map and reduce second phase. Now, what is wrong with this approach? One, there is lot of serialization and deserialization. Second, lot of serialization and deserialization because we are converting an object into disk and again loading it and parsing it and loading it again. So that's what is happening. Ideally, if they had communicated in using memory, it could have been faster. It is slow. I mean, very slow. This approach is very slow. Now, if you try to do the same thing, if you try to represent the same thing, it is like this. Memory, MapReduce 1, then again memory, and then MapReduce 2. This is what Spark looks like. Okay, this is our traditional MapReduce look like. All right, does it make sense to you? Also, the other aspect of Spark is that it provides more functions than only map and reduce. Okay, you will see that, which means you have more control over data. You are not helplessly dependent on only map and reduce because map and reduce is very limiting. All right, now the Savna is it runs your mapper on the data. That is correct. All right, moving ahead to next question. So Sanjay's question is, what does it mean by persisted in memory? Okay, let me try to explain. You remember our big discussion where we created data equals to load some data, right? Now, if this program, needs the same data again and again, you'll have to compute. If this data is required again and again, this data will be recomputed. Okay, if we have data, filter data, and where blah is blue. Okay, so like this, right? So if we need a again and again, then we have to again and again load this data. If you say dump a and dump a, right, both the times this whole process will run. Now, so that is the downside of doing it again and again. What if there was a way to just say persist a, meaning keep the copy of all of this into the memory, so that when we say dump A, all it needs to do is take it from memory and dump it to the user's screen, right? In the similar fashion, the RDDs are also computed in a similar fashion. Load data from here, clean up the data, and all that. An RDD is also a chain of dependencies, that these are the steps that are required to compute this RDD. So you can cut those steps by saying persist. It's like caching the data in the middle level. All right? Does it make you clear? Great, brilliant. All right. So now question is, now when we say persist, the question from Lloyd is, if RDD is huge, it will overflow the memory or spill to the disk. Okay. It so whenever we say persist, right? Persist has options. You want to persist it partially to the disk, spill over to the disk, or you want to keep it all in memory, or you want to keep it all almost everything into the memory. So there are these options using which you can persist in RDD. RDD by default does not take up the memory. RDD is just a representation that, okay, these are the steps that are required to compute this data. RDD is exactly like the data set in pig. Okay, it is not, it is basically a chain of steps required to compute a particular data set. It is only this persist which loads this data into the memory. Okay, so persist has options whether you want to spill over to the disk, or you want to keep it all in memory, or you want to just load whatever you can and leave everything else for the recomputation. So you can do anything you want. Persist provides a lot of options. Very brilliant questions. So Sanjay's question is RDD a global array where the state of the elements can be referred to by the machine, by various machines in real time? Okay, so RDD is like a global array where the state of elements, yes. So RDD is not a global array. It's a global array. You can say it's a global array, but it's not available to many people at the same time. Okay. Also, RDD is partly located on one machine, partly located on another, and so on. But on top of all of this abstraction, it represents to the user as a single data structure. All right. All right. Same was the question from Sarvana. Doesn't that overflow the memory? I hope you got the answer. Yes. So again, the you mean the disk instead of memory? Yes. Yes, sometimes we need a lot of memory to run Spark, and when you're persisting, if you are persisting only into memory, then what it will do is, if it could load part of the RDD into the memory, it will load. Otherwise, it will leave the rest of it for recomputation whenever required. All right, that is how Spark handles it. Okay, again, RDD is a representation of data where part of the where is which element located in the cluster. Okay, so it will basically, RDD is basically a mapping of the data of the various element with actual data. Okay, and also RDD also has the backward steps, as in these are the steps that are required to compute an RDD. You can persist an RDD to avoid all the steps to reach to a level. And okay, all right. So I should have been little more clear with the definition. What does resilience mean, imply in RDD? Good question. I should have been clear in the first step. So resilient means something that bounces back into the shape. Okay. When you damage something, something like um, elastic ball, where you try to press it and then leave it, it bounces back into the same shape. Okay. So that is called resilient. Similarly, in case one of the machines over which RDD has been created. So let's say, as per the diagram, this RDD is loaded on 4 machines. 1, 2, 3, 4. If one of the machine goes down, the same section will be quickly loaded on fifth machine, which might be available in the network, or if there is no other machine located in the network, the same section might be moved to any other machine. All right. Now, Lux's question is, how is this different from clustered cache? Apart from that, it runs on HDFS, etc., than normal disk. Okay, so cluster cache is something which is made available by Hadoop to individual job. So it is actually similar to that. Okay, clustered cache is what? When Hadoop runs a job, it makes your data available on all disks. Okay, here now in case of clustered cache, all of the data was on one node. Okay, a copy of the whole data is given to all the nodes. Here it's a single data structure, it's a single representation of data which is distributed across the cluster. So few elements on one node, few elements on another, few elements on another. So RDD is basically kind of keeping the pointers to the data, and how are those pointers going to recompute. That is an RDD. All right. All right. Now, so we were able to successfully create two RDDs. One was lines, and other was, what was the other? Otherwise, my array. All right. Now we have these two RDDs. Now what can we do with these RDDs? I think that will make more sense to you. So on an RDD, so RDD you can imagine RDD just like a data set in case of pig. In pig we said A equals to load XYZ, and that A was the data set representing that file. All right. Just that, just that in case of pig, the end result is evaluated by Hadoop's MapReduce, and here run, when you execute the RDD, the actual evaluation is happening via Spark. All right, but both are running on Yarn at the end of the day. So let's have a look at what kind of things you could do on Spark. So on Spark's RDD. So first there are two broad categories of functions that could be executed on an RDD. Just like we had filter, we had group, we had for each in pig. In the similar manner, Spark also provides you similar functions, but in two large buckets. One is called transformation, and other is called action. Okay, so a transformation translate one RDD into another, just like in case of pig, transformation was translating our dataset into another data set. The only problem with pig was that pig was a very restrictive language. Here it's a full-fledged Python kind of Python or Java or Scala language in which you are writing these functions. Okay, you are not restricted by pig as a language. Okay, in case of pig we has very rudimentary, very small language which was which had limiting functions. Every time we need something we had to do UDF. Here that is not the case. You are writing these transformations in Python directly or Java directly or Scala directly. Now let's have a look at what does it mean by transformation. Transformation creates another data set from one data set. Okay, so if you have an HDFS from which you created this RDD, you can convert this RDD into another data set by using transformation. All right, let's say we were talking about our lines, right? And what does line have? Line have let's say, just let's take 10 records. So line has each element from here to here. You can see this is the first element, and from here to here is the second element, from here to here is third, from here to here is fourth. Okay, now let's transform this RDD into something else. Let's say we want to convert it into lowercase. We want to convert all the text into lowercase. How will we do that? Okay, we will do that using a transformation. All right, now what kind of transformations are available? There are many transformations that are available to you. Okay, the first one is map. All right, so first transformation which is available from Spark is map. So pay close attention to this particular function. This is probably the single most important concept of any functional programming or of Spark. Okay, what does map do? So map accepts a function pointer in the argument. Map accepts the function definition as the argument, and it takes this function and applies on each element of RDD. Here our our RDD is composed of the lines. Each element is a line. Now if we want to operate on each line and translate this line into something else by the virtue of function, let's say we want to translate this line into lowercase, so we define our function called myL, meaning my lower function, and whatever string you pass to it. Right now we are doing the coding in Java. Okay, so this is our Java function. What it sorry, we forgot to return. We had to return x dot lower. Okay, now pay close attention to it. When I say my lower, and here if I say something like this, we are testing our Python function whether it works or not. So our myl function is just perfect. It is translating the uppercase into lowercase. So this myl function we have written in in Python. All it does is whatever you provide in the argument, it translates it into lowercase. All right. Now instead of writing a for loop, we use map. Instead of writing a for loop and iterating over this full RDD one element at a time, we say map. Map means take my function and run it on each element the way we have just run our myl function on this particular value called the x. Okay, similarly map function will run it on every element of RDD. Let's try to see what exactly is this. So we say lower lines. Okay, we say lower lines equal to lines dot map, and we provide the pointer to our function, the definition of our function. What would it do? So you can see lines dot map. Okay, and myl. So this function called myl will be executed on every element of this array called lines. Array as in it's an RDD. So it will first apply on this up to here, then on this, and then on this, and whatever is the result it saves into another RDD. Okay, now we can say take 10, and you can see that everything has been converted into lowercase. You can see that it has been converted into lowercase. Sounds good? Similarly, if we had to compute just the length of each line, we could have written our function called define line length. This is the function which we are creating right now, and whatever line we pass to it, it would give us, it would return the length of that particular line. It should have, basically we could have named it simply. So if we call on something like this, it will give us the length of this string, which is 13 characters. Okay, now if we say ll line lengths of RDD, we are saying lines dot map, and we pass another function this time called ll. What this ll is going to do is it's going to run on, this map is going to run ll on every element of lines. And what will we get in LLRDD if we say take, again only 10 elements right now? So you can see this is the length of first line, second line, third line, and you can see the fourth line is 0. If you remember, if you go up a bit, this was the 0 length, correct? So we are able to successfully execute our function against each element of the RDD and translate the RDD into something else. All right. All right. So RDD is read only. Let me mention that in our first description. Okay. RDD is read only. All right. Keep that in mind. And that is why we are just translating one RDD to into another. If we go to the old one, still it will be there. Okay, if we say 10, it is still the same thing. Okay, that was the answer to I think Lux's question. All right, that was the answer to Lux's question. Now, all right, so Sarvana's question is how the RDD elements is getting created. We did, if you remember, if we did few things. We earlier we ran these three commands. All right, one was this command, other was so using this we converted our HDFS file as an RDD in lines. Okay, we are saying as c.text file, and we provided the URL of HDFS file. All right. All right. So in lines RDD, each element has different length. Yes. Why? Because the file which we are operating upon, let's just have a look at our file. Okay. So let's have a look at our file. Okay. Let's have a look at our file. Here. You can see that first line has got some length, right? Second line has got some length, and third line has got some length, and fourth line has got empty. And that's what is here, right? Okay, does that answer your question, Savna? All right. Now there is a question from Sanjay. RDD transformation always requires another RDD as dataset. Yes. RDD transformation is one RDD, RDD1, and then we feed it to the transformation and we get another RDD. Using Spark, there is a question from Lux. Using Spark mandate different hardware spec than traditional Hadoop cluster? Not really. Not really. Why? Because this RDD is partly into multiple computers. Okay, so it is not necessary that all of it has to be loaded onto one computer. Okay, so memory is not that big a constraint as it looks from the distance. Okay, now there is a question from Lloyd. If you read a file from local, Spark will still do the computation over the cluster. So whenever you are doing text file, even if sc.text file, okay, and you are saying file colon slash slash, okay, like this. So what would happen in this case? I'm trying to explain to you this kind of scenario. So you're trying to specify a local file, and when it's trying to load this file, the cluster is trying to load this file, what would happen is it would it would load everything, everything. It will try to load, it will try to find the same file. Let's say our file is in say slash data slash sgiri slash x dot txt. So this is the location I'm providing. So Spark will try to find this file on all the machines at exactly at the same machine, exactly at the same location. If you do not want to do it computation over the cluster, you can continue to use your programming language in your own way. Okay, the way you have been doing traditionally. All right, you use Spark only when you want to do things parallelly on the whole cluster. You don't otherwise use Spark for fun or for any good practice or bad practice or some software design practices. No, you use Spark only for distributed computing. All right, if you have if you have only the file on a local machine, then what you do is you first load the data into this local machine, and then once you have loaded this data into the machine, then you do things like sc dot parallelize. Okay, and that way you will convert an in-memory data into an RDD. Was he able to answer your question, Lloyd? Now, next question from Sanjay is good, good. So next question from Sanjay is that if we do not need an RDD out of multiple transformation, how to get rid of them as they will consume memory? Okay. So what you can do is if you again, let me again rephrase what I'm saying. So RDD will consume memory if persisted. Okay, if you call persisted. If you call persist on an RDD, only then it will consume memory. Otherwise, it will not. Alright? In case you want to unconsume the data, you can call unpersist. Okay, it will convert an RDD again into the chain of expression on what transformations are involved in on what data to reach to an RDD. So RDD could be an steps such as load file X, run function X, function some Y, function Y on as map, etc. Okay, this is an RDD traditionally, or or RDD is a persisted RDD is the actual data either in memory or in disk, distributed across cluster. Sounds good to you? Is there a difference between persist and cache? Cache is basically persist only, not much of a difference. Does it have a cache function? I doubt if it has a cache function. If it would be deprecated by now. All right, very brilliant question, I must say. And all right, really good questions. All right. So moving on. Now we were able to run map function. Now quick question to all. If let's say we said, well, what did we do just now? We were running we had run this, right? We had run something like this. Question to all of you is, if lines had 1,000 elements, how many elements would LLRDD would have? Anyone? We can call say lines dot count, and it will return us the length of. So okay, quickly, if lines has 1,28,457 elements, these are the total number of lines in that file, then how many elements does LLRDD has? Anyone? After this statement, what we have done is we have run this particular function on each element of lines, and whatever was the result, we have saved it here. So if lines, which is an RDD, has these many elements, how many elements would LLRDD have? Correct, correct, same. Thank you, Lloyd. So same as this one. Why? Because map is one-to-one function. Whatever is the input, because for this one, our LL function is returning one value for one input, and therefore one value is getting translated into one output. Okay, thank you, Sanjay. Thank you, Saruna. You are right. It will be the same. Great, great, great going. All right, so we have this map function which translate an input RDD into something else, right? But it has the same number of elements. Now, quick question to all of you is, I think we have already asked this question, so let's just move on. Now, sometimes you want to remove certain elements from our input. We don't want certain elements from our RDD in another RDD. Let's say we do not want blank lines. Okay, out of these lines we do not want blank lines in our another RDD. So let's say we are creating no blank lines, and this is another RDD, and we say lines dot map, and let's first define what kind of function would lines dot filter. So for such kind of scenario, when we do not want certain elements in our output, we can use filter. Just like in pig we said filter data by sum. Similarly, we can here say RDD dot filter, and here is my function, and this function need to return true in case you want to retain an element. In case you want to remove it, the function need to return false. So define my filter function, and if length of line, okay, how did we write earlier, length of line equals 0, or it should just return length of line not equal to 0. Let's try to create this function and let's see what happens. Okay, so we've just defined our function called myf. Let's test it. So we are passing an empty line, so it says false, meaning, and we are passing something in the line, true. Perfect. So that means the function works. Now let's feed it to our so here we have to say lines dot filter, and we say myf. Okay, now it will filter, this myf will filter, okay, is going to remove all the values for which myf returns false. It will remove those elements from, it will not put those elements into no blank line. So for the elements for which myf returns true, those elements are going to go in no blank lines. Otherwise, those lines are not going to be in the output. Let's try to see what happens. No blank line. No blank line dot collect. Not collect. Collect will bring all the records. We'll just say take first 20. You see that now that empty line is not there. All right. Similarly, if we had to do if we had to remove out of line length, you remember our line length? What was that? LLRDD? Yeah, LLRDD was having line lengths. Let's say we take 100 elements. So these are the line lengths. We want to retain those line lengths which are even numbers. We want to retain only even numbers. So we define a function called isEven. Okay, and what does this do is it basically returns x divided by 2 equals to 0. It's basically checking the remainder after dividing by 2. So we can say 3 and it'll say false. See, if we say 0, it'll say true. It'll say for 2. So isEven is good. Now on this only even equals to LLRDD, that was our RDD containing line lengths, and we say filter is even. So we can say only even dot take 10. You see, only even numbers are there in the output now. So this is what the filter does. Next is flat map. Sometimes one of the elements need to generate multiple values. For example, let's say we want to convert our lines into one word per line. Okay, for example, let's say this is a line, this is one element in our RDD, and this is another element in our RDD. We want to convert such thing into something like this is a line, so that each element in an RDD can be operated upon. Okay, like this. You see, so we are trying to convert each line into one word. So here, this particular RDD is having this is our lines RDD. Okay, this is our lines RDD, which contains every element is a line. Let's say we want to convert it into such that every word is a line, so that our map function, because our map function applies on one element at a time. It doesn't apply on each character or anything. So our map function will get full element in an argument. So if you want to convert it such that our map function, when we apply, it should get one word per time at a time. So what we can do is we can use flat map. Now let's say two words is a function which takes a line and returns the words. Okay, line dot split. So this two words function will return us for any line which we pass in the argument. It will return us the array of words. See that it has split the line into words. Okay, now we can use this to generate our new, what do you call, okay, so we can use flat map to do this. In case your one element from one RDD needs to get converted into multiple elements in the resulting RDD. If you want to convert one element into multiple elements, you use flat map. Because in case of map, you could only translate it into one element into another element, not one element into multiple elements. Okay? So when we say words dot take 10, take say 100, okay, you will see that it has got one element at a time. Now if you apply filter on words, you will be able to remove some of the words. All right? All right. So there is a big paradigm shift. Instead of writing for loops to iterate over an array, you are utilizing these functions like map, filter, and flat map. Ideally, in our typical programming scenario, we would have for loop for each of this. We'll say for I in this, go over this data. If this is this, then put it in the output. Otherwise, don't do anything. So all of these three things could be done into using for loop. Now problem with the for loop is that for loop is not something which can be distributed onto multiple processors or onto multiple machines, and thereby we do not use the iterations. We avoid iterations. Instead, we do the set based algebra. We try to apply a function on the data. If you are from database background, you would be aware that we do not iterate over the data one by one the way we had been accustomed to go on an array elements, right? We when we talk about data in database as well, we never try to iterate. If you have gone through MS SQL or Oracle, they all say that don't use our for loops. Okay, because you will always end up overflowing the memory. Sounds good. All right all right there is a question from Sanjay: how to refer each element of an RDD, like RDD1, RDD2. My quick answer is you don't. Okay, that's exactly what it is against. So if you want to iterate over a data set like this, what you can do is you can bring your data back from RDD to local machine and then iterate. Okay, because if you try to refer to the data set like this, because every time you refer the data like this, you are going to bring the data from RDD back to the local machine, and if you put a for loop to do this, it is going to be a disaster. That's why RDDs do not support the referencing like this. Okay. Generally, RDDs provide you an ability to take some amount of data, like using take or something like um, uh, count, or it gives you a functionality like collect, where you can bring all the data back to your local machine. All right, good. Now the next, so we talked about flat map where we want to convert one element into multiple elements. Then we use flat map. All right. In case you want to group the elements by key, then you can use group by key. All right. That is about transformations. All right. Moving ahead. Now, these were transformations. A transformation was always generating another RDD. Now, what if you don't want to generate another RDD? What if you want to bring data back to the node? Okay. In those cases, you use action. Action brings data back to the node, or it does something. So while we were doing transformation, nothing was being executed. Everything got executed the moment we said take. Similarly, when we said count, when the things got executed. So take or count were our actions. These were the actions. Actions make transformation happen, exactly like our pick, where when we said dump, only then the whole process is started. Here, instead of dump, there are many functions under that class class of actions which make things happen. Whenever we did transformation, it accepted things silently. I'll show you this. So when we say this, it accepted everything quickly, as if nothing has happened. Actually, nothing has happened until you say words.count. Now the moment you say word.count, you see a lot of things are happening. The actual execution starts the moment you execute an action. An action could be take, an action could be collect, an action could be count. Okay, and there are many more actions. If you look into the library, you'll find lots and lots of actions. Okay, now count is straightforward. Count will count all the elements in the RDD. Collect will bring all the elements from the RDD to local machine. And take will bring these many RDDs from the top. And there are many more functions. You can have a look at the the Python RDD. Python RDD. So yeah. So this is a very good documentation. I think I'll refer to that one rather than this Java one. This Java one is old. All right. So here there are many more functions under each of these things. All right. So you can see there is, starting from here, you will see all kinds of functions which can be applied on an RDD. All right. There are many more functions that are there. Out of this, these three are very straightforward. Reduce is something which we need to understand. Reduce reduces your whole array into a single value. Reduce reduces the whole array into single value. Okay, and also note that the beauty of reduce function is everybody with me? Are you able to hear me? Because it's saying to me trying to connect. Are you able to hear me? Connection is lost. Hi, are you able to hear me now? My connection got disconnected, and that's why the whole disaster. All right, just give me a second. All right. So, all right. Could you confirm once more, please? Are you able to hear me and my voice is clear? All right. Great. Let's try to do. So we were talking about reduce function. This is something most interesting and important. All right. So a reduce function is something which reduces the full array into a single element using a function which converts two elements at a time. Okay, let's try to see what could be done. Let's say so sketch. All right, let's say you have this function which takes two elements and converts them into a single element. It takes two elements and converts them into a single element. All right. This is the function. This is your reduce function, which takes two values and converts it into one value. It could be a reduce function could be, let's say, okay, a reduce function could be define, let's say sum x comma y, and it returns a single value, say x plus y. So a reduce function is an interesting function which takes two values and returns one. Okay, visually we can represent a reduce function like this. It has taken x and y and return sum of x and y. Okay, this is how you can represent. Now what if, okay, so let me, yeah. Now, let's say you have got a huge array. Okay, you have got a huge array of element like this. Okay, if you want to reduce this into a single value, you can use this function called reduce, which will execute whatever reduce function you provide in the argument and convert it into a single element. Let's see how. Okay, let's see how. So these two values will be converted into single. Let's say these two values are being converted into single value. These two values are being converted into single value. Again, these two values will be converted into single value, and whatever is the result of these two values will get converted into a single value. And that's why this will be your final result. Okay? So here, and here. So this is your final result that you are looking for. So your reduce function first was called here, then called here, then called here. So 3 plus 4. Okay. So here also it has been called. So what do we see is using a single function, we applied that function again and again over the whole RDD to convert it into single value. That is the job of reduce function. Okay, that is the job of this reduce function on an RDD. Okay, so basically the important part to understand is reduce function is, if you look at it closely, So here the function which we have defined, say sm will be executed on this value and this value, and then whatever is the result, it will be saved here. Let's say it was 2 and it is 3. So, and our function definition is x plus y, which means this will become 5. All right. Then another is, let's say this is 3 and this is 6. This will become, quickly, anybody, 9. All right. Then, and so on. So we could apply a reduce function. You define a reduce function once, and this reduce function is going to be applied on all the elements of this RDD until this whole array reduces to a single value. Okay, now is the definition of map and reduce sounds very clear to you? Map means mapping one value to another value, and reduce means reducing the whole array into, it crumble the whole array into single value by folding two values at a time. By reducing two values at a time, you are converting recursively the whole array into a single value. All right. Now, as you might understand that not all functions are eligible for this kind of job. Do you remember our combiner with the one which we discussed earlier? In the same way, not every function is eligible for being the reduced function. For example, let me ask you this. What would happen to the scenario where we have our reduced function something like average? We have something like average. Is this a valid reduced function? Is this a valid reduced function? Correct, correct. It is not a valid reduced function. Because if you try to execute it, my connectivity did go wrong. All right. All right. Coming back here again. Now we can define our average function and try to do compute the average. Or let's first do the simple thing first. All right. Where was our line, the way we loaded the line? Have we stored that somewhere? Yeah. Okay. All right. Let's say we have line length equals to, all right. So let's say, what do we say? We have this reduce function. Okay. And what does this reduce function do is it finds the maximum length. Okay. Max length, line 1, comma, line 2. Okay. It takes two lines and then it compares, um, if length of line 1 is greater than length of line 2, it returns line 1, otherwise it return line 2. Okay, I made a mistake. I'll have to write the code again. All right. Ouch. I think a better idea would be to copy this. Indent is a little problem sometimes, but mostly I'm okay with the indent. Right? So what I'm trying to do is I'm trying to find the longest line in this file using a reduce function. Okay? Alright, sounds good. Alright, so max length, let's try to test it first. There is this is and there is this. Okay, out of this it has returned us this is. Okay, now let's try to find out the longest line in the file. Okay, semicolons are not required in the in it's just optional in Python. Okay, and also we don't have to define the data types, it will infer the data types by itself. Okay, now let's say we had these lines, right? Now we say lines dot reduce and we call this function called max length. Now the whole process has started. So you see, this is the biggest line in this file. Sounds good? This is the biggest line in this file. Alright, so you could use the reduce function in variety of ways to reduce. You can write any logic you want without having to worry about the functions provided by Spark or not, because this is your Python function. This is your Python function. Okay, you're basically applying your Python function again and again and in a distributed fashion. Sounds good. Now, if we wanted to compute the average of some values, let's take a case of average. All right. Let's first create, let's say nums equals to sc dot parallelize, because we are trying to convert an in-memory data structure of our arrays. Okay. So if we have this. Okay, first I think we have average function here. All right. Uh, so let's say sum. Yeah, sum is this much and count of the same values. All right. I'm just multiplying it in order to make it a decimal number. All right, sounds good. So the average of these numbers is 37. Okay, let's note it down somewhere. All right. This is the known average of these. Now let's try to compute the average. Our AVG function was this, which computed the average of 2 and 3. So it takes two values. Now let's try to do the average part. Okay. Now we have nums. Nums is our array which we have defined earlier here. So we are saying nums and we have defined our AVG function which takes x and y and returns x plus y divided by 2.0. Okay, so this is our average function and now we are trying to use this AVG function to compute the average value. Let's see if it works or not. Okay, we'll say nums dot reduce and we pass the function. Okay, we pass the function and let's see what happens. Okay, you can see the value must have been stored in AV and the value is wrong. See the difference? The value is wrong. Therefore, an average function is not a valid reducer. You use only the reducer function which are a valid functions, which are commutative and associative. No matter how many times you apply the same function on the output, the result is always the same. Okay, such as min, max, and also we had already discussed something called square root of sum of the squares of values, so that on the resulting value, if you apply the reduce function again, the value is same. So there are similar constructs. There are some more constructs such as combine and aggregate in Spark actions. There are actually 30-40 functions under action and 30-40 functions under transformation. And using these basic constructs, things like compute the standard deviation, compute the variation, all of those kind of things have been developed on top of Spark. Okay, you can take a look at this particular API. It has more details about this. Also, the way reduce is being executed on all the nodes separately first, and then on the resultant of every node, it's reducing again and again. For example, if we are computing line lengths, you sum of the line lengths of all these values, what would happen is, let's say, out of this full data structure out of this full data structure out of this, some values are on node 1, some values are on node 2, some values are on node 3. On each of the nodes, let's say the line lengths that are computed is this is overall standalone. Let's say line length is this, and line length is this, line length is this. Now when we say sum, okay, when we try to compute the sum of this particular line length RDD, which is distributed on 3 nodes. Line length RDD is distributed on 3 nodes, node 1, node 2, node 3. Now we are trying to compute the summation of line lengths. Okay, we are trying to compute the summation of line lengths. So first part summation will happen on first node. First 10 and 9 got combined into 20, then 20 and 4 got combined into 24. So on node, lines and sum of line lengths is 24, node 2 it's 14, node 3 is 24. Now all of these three values will be bring back to the node which launched the whole process, the driver node. We call it driver node. And this driver node bring basically again applies the reduce function in the same fashion. It will sum up these two and then sum up the resulting one, and the line length will be 62. All right, so that was about reduce function. So Spark provides multiple such actions, okay, to do various kinds of computations. Now, other than RDD transformation and RDD actions, it provides something called broadcast variable. Just like distributed cache, using which we send the amount of data to all the nodes. In the same manner, Spark also provide broadcast variable. Using broadcast variable, you can transmit the data from your driver is the one from which the things get executed. So Spark has got a driver, and driver execute things on all the nodes. Okay, right now our driver is this. You see this command prompt, it has created a driver here. Every time we are doing something, it's telling the nodes to do things for it. Okay, now this driver can send the broadcast variable to all the nodes, specifically when you have to send some amount of data to all the nodes, just like the way we did in case of distributed cache. Okay, now we have something called accumulator. If we have to continuously accumulate values from all the nodes, let's say we are continuously monitoring the progress of our word count program. Then we will like to we would like our map function or reduce function to continuously report back the values. Okay, so accumulators are such cases. Accumulators are good only when the order of values do not matter. The order in which the values are coming from multiple nodes, it doesn't matter. Okay, also please note that in case of accumulators, it's only one directional, it's not both directions. The data is transferred only in one direction, from the node to the driver, or executor to the driver. Executor can never access the value of accumulator. Okay, so those are called accumulators. All right, so here is a word count example, full word count example. You can try to execute this. We have done execution of it partly. First, we loaded data like this into lines RDD from HDFS. Then we converted these lines into the flat map, into the words using flat map like this. Okay, here this way we have converted it. All right. Next is, once we have converted the lines into words, we are converting the lines into each word into key value pair. Okay, by mapping the value like this, word becomes word comma 1. Okay, so we get the words key value pair, and once we are done with that, we are summing up all the values. Okay, we are saying reduce by key is an action, and reduce by key is a action actually. Okay, reduce by key groups the data by the key, and on all the values it calls your reduce function to convert the full array into a single value. So here your sum is being called on all the ones for each of the keys, and thus converting all the values into a single number, that is the count of each key. And that's how we compute the word count. All right, so we can run. So what exactly is wrong with this? All right, we define this two lines to words. Now we are defining words. We can test if words has something meaningful. Yeah, it has converted this into words. Now let's convert each of the words into let's try to do this, and then now words kv dot take 10. Okay, we're just checking. See, it has converted each word into key value pair. Now words kv is good. Now let's try to do the reduce. Okay, again we'll have to put a new line. Okay, now WC has got the results. Let's take a look. You see, it has computed that empty lines are these many. Okay, and so on. Now we want to save this result. We can save the result into our HDFS file. Okay, let's try to save it in our folder, and our folder is Hadoop 17. Okay, let's try to save it in our HDFS folder, and we say Hadoop 17, and let's say output. Okay, Now once it is done, it will save the results in our home folder. And again, there will be an output folder somewhere. Not here. We'll have to go to user, and where is Hadoop 17? Here. And then under that, we will have output. See that? It is created. So it has done the computation for us. Okay? You can do the cleanup very easily. You can remove all the special characters, convert it into lowercase. It's very straightforward. You can just take the same code, and here when you are converting it to two key value, you could clean it up like this. Also, here while splitting, you could remove the special characters, okay, and so on. Also here, if you want to remove new line, you could place a filter function. All right. Also, what you can do is, for the cases when line is having zero value, you can return empty array here. Empty array means no element should be added in the output. So that means flat map not only increases the number of values in the output, it can also decrease the number of values in the output. Okay. So if for each word in flat map, if you return the empty array, it will remove those elements. Sounds good? Sounds good to you? Now the same code what we have done above, same code with little bit more sophistication by removing special characters, converting into lowercase, along with tracking the progress by using accumulator is done. The way you create accumulator is this. You say accumulator equals to sc dot accumulator. Similarly, broadcast variables, the way you create is sc dot broadcast, and you put the array. And to access the accumulator, you can simply say in your program, you can say accumulator dot add. All right. And to access the the common, which is broadcast, you could use common dot value. All right. So these were few things that could be done. All right. So this was our crash introduction of Spark. Let's move to Spark streaming. All right. But before that, let's take a break for 10 minutes and come back. All right. right. So if you have any questions, you can start asking now. If you are here, I'm back a little early today. All right. All right. So Spark does have it does have some UI. The question from Lux was, does Spark has any UI? It does, but only for monitoring. Okay. It doesn't have something like where you can code or something like that. It doesn't. Okay. It only has this kind of a UI where you can see what are the jobs running, what are the stages, and where is the storage. All right. All right. So I think let's start the session. I think we talked about only. All right. So let's start. So there was a question from Lux. Question was, does Spark has any UI? It doesn't. It has one monitoring UI and other is for tracking the log and debugging. And it's not integrated yet with Ambari, but it hooks itself to Yarn's UI. If you can to right now the way we are running PySpark, it's in the standalone mode. We are not running it on Yarn right now. To run it in Yarn mode, what you can do is you can say Yarn config folder, config file, config directory, I think, equals to the etc Hadoop conf. Okay, and then PySpark, while running PySpark, you can say master equals to yarn, and then it will anything you run, it will run on the Spark. All right. So th- and when you run that, and the tracking URL which is given by MapReduce job usually or yarn usually will have the UI of Spark. Okay, this UI will be shown to you. All right, so it hooks itself to the yarn UI in detail. All right, that was one thing. Next question from Sanjay is Spark the future of big data computing? Cannot say. Okay, but given the given the amount of work, giving the amount of support right now, a lot of work is being done in Spark. All right. Ooh, okay. I'll avoid typing because that's consuming too much time. Now there's a question: how do we call Spark script? So all you have to do is, if you have this code, let's say you have this particular code, you can save it in a file. Okay, you can save it in a file and then execute it using say using Spark submit, and it will run. You say you have saved it in myprog.py. You can execute your program like this. All right, you can execute the script like that. All right, now I'll just copy paste it in the discussion document. Sounds good. All right, so moving on, then there is something called Spark streaming. Streaming as a concept Streaming as a concept means multiple things. We should keep the definition of streaming very clear. When we say video streaming, meaning watching a video, okay, or downloading a video. And when we say streaming our data through a process, that means we are running we are running this process on every element of our data. Then there is a stream processing, also called streaming. Stream processing means data in real time is coming from the sources, and then we are processing that data and saving it somewhere. And generally these sources are queues. Queues are very good, very, very common form of carrying the data in organizations. And the important part is, in case of stream processing, the process is always almost running. Okay, stream in case of stream processing, the process is always running. Either it's actually churning the data, or it's waiting for the data to come in the pipe. It will just keep on waiting on the pipe, or on the queue. All right, so that is stream processing. It's an extension of core Spark API. It's high throughput and very highly fault tolerant. So some of the people realize that the RDD could be a great place for keeping the streams of data in real time, and then remove the data from RDD as soon as the work was done. And that's where the Spark streaming came into play. Spark streaming is nothing but a small library which basically converts the incoming data into batches of data. Okay, it basically reads input data stream from various sources and creates batches of data into an RDD. It creates an RDD that contains batches of data, and on this RDD you can run your function in whatever way you want. Okay, and as a matter of fact, whenever we say stream processing is always about converting high frequency data into into the batches of data. Okay, so on top of these batches of data, you can run your map, you can run your reduce, you can run anything that you can run on an RDD. All right, so basically, in case of Spark streaming, the whole idea is surrounded around D stream. Okay, and a D stream is basically a RDD, basically an RDD where each element in this RDD is basically batch of values. All right, so in window, whenever we talk about stream processing, we are basically talking about window operation. We convert our high frequency data into a window of data, and on that window we do various kinds of operations. All right, so for example, here we could do operations like pairs dot reduce by key and the window. Okay, and the window's duration is this much, and reduce our reduce function is this much. Okay, so it reduces last 30 seconds data every 10 seconds. So it provides you these kind of nice functions. All right, so here is a good example of running Spark streaming. So your problem statement is, what is this? Problem is, do the word count every second. There's a large amount of words coming from the user or coming in a queue continuously, and we have to do the word count every second. So what we do is, first we create something called Java streaming context. This is in Java we are writing. So we create this Java streaming context. And what does it say? It says that our duration of a window is 1 second. All right. Now we read the lines from our JSS, JSSC. It gives us 1 second's data in this line. All right. And then we say on this line, we run our flat map, we get words and then do the word count as usual. Okay. Do the word count as usual. All right. Using reduce by key and then exactly in the same fashion. So what is important here is that this data in the input is coming in the form of D streams. We have converted lines into windows of 1 second each, and then by using the flat map we are converting these lines on each of the element into words and so on, and then we are doing the same operation again and again on the same data set. All right, this will keep on happening on every second. So effectively we will be able to do the real-time processing just by converting the input data streams into RDD, such as every element represents a window of elements. Okay, so that's what is Spark streaming about. All right. So Lux's question is, RDD is read-only. How does Spark appends constantly streaming data? It does not. Okay, it keeps creating new RDDs. Okay, for every window. All right. So that was very quick overview of Spark streaming. Basically, it's using the same core concept of RDD transformation and actions along with broadcast and accumulator to give you a real-time processing engine. And it's real-time because the RDD it uses is generally in memory. Okay, that's why it's fairly fast. All right. Now the next is the Apache Storm. So Apache Storm was the one which we always used in case of doing stream processing. Apache Storm was well known for its computational system, similar to any other stream processing. So whenever you had to do real-time computation, you generally used Apache Storm earlier. It was created, I think, Storm was created, I think, at Twitter or Yahoo somewhere. It reliably processes unbounded streams of data, can be used with any language. It has got, it is really fast. It was benchmarked at more than 1 million key value pairs per second per node. Okay, and is heavily scalable, fault tolerant. It guarantees your data will be processed, integrates with any queuing or database technology. After a certain point of time, you will realize that queues and databases are almost the similar in behavior. For that matter, the queues, the AS queues provided by Oracle is nothing but database. All right. So it integrates with queuing and database technologies very well. So we are comparing here Spark streaming and Apache Storm. So Apache Storm, the use cases of Apache Storm is real-time analytics, continuous computation. Continuous computation is a different aspect of computation altogether. Generally, your program ends. In a continuous computation, your program never ends. So you always have to plan various kind of strategies to test such continuously running operations. Whenever we have to provide distributed RPC, as in, let's say we are doing crawling and we want to make calls from all hundreds of nodes parallelly to some services, then you could use Storm. You could also use online machine learning in Storm, and there had been lots and lots of users of Storm so far. But but lately, since lot of libraries are not available in case of Apache Storm, therefore the the computation is being moving to the Spark streaming. Now here is a slide which will help you understand when to use Storm and when to use Spark. All right. So in case of Storm, the processing model is one record at a time. While in case of Spark, we handle many batches of data. Latency of Spark Storm is less than a second. Okay, while the latency in Spark might be close to few seconds sometimes. Okay, generally it's lesser than 1 second or 2 seconds, but in worst case scenario it could be few seconds. With respect to fault tolerance, Storm guarantees that every record is going to be at least processed once. Sometimes a record might be processed twice, but it will be at least processed once. In case of Spark, it is processed exactly once. With respect to the general implementation and API, Spark was basically conceived at UC Berkeley, and Storm was uh, conceived at the time of Backtype in Twitter. Twitter was Backtype before being Twitter. It was implemented as Closure in Closure, a programming language called Closure. While Spark was implemented in Scala, API language in case of Storm was Java and others. In case of Spark, now Python as well, along with Java and Scala, you can use that. The batch frame integration is not there in case of Storm, but in case of Spark, there is with the normal Spark core. Now, with respect to the production and support, Storm can only run. It has been into use since 2010, and it has been used. Spark has been used since 2013, and Storm comes with Hortonworks, while Spark comes with Cloudera and Mapr. Storm doesn't have a support available, while Spark has got a dedicated company called DataStax and Databricks. There are two companies who support Spark. Now, resource manager integration in Storm is Mesos, while in case of Spark, it can run on standalone, Yarn, or Mesos. Alright? Storm has run in production much longer, while Spark has got better production support. Therefore, I would always say that if you have a requirement of far less than 1 second, then you go for Storm. If you are okay for a latency of 1 second, you should go with Spark. All right, because Spark has got far better supports for the input formats and far better support for all kinds of algorithms on it. All right, we will go through the various NoSQLs quickly available so that when you are taking a call which has NoSQL to use, you do not have any confusion. So is everyone clear about Storm and Spark? Great. All right. Any questions at this point of time? All right. Moving ahead. So we will just quickly skim through the normal popular databases. For example, under NoSQLs, there is a database called Redis. Okay. So every data, whatever you store in Redis is available in memory. Although it's saved in the disk, but is also available in the memory. So whenever you think about Redis, you think about it as in memory. It's extremely fast because whole data is in memory. Also, complex data structures are easy to handle in memory databases because in memory means it in the RAM. RAM means random access memory, which means you could quickly dereference the pointers, and every element or every object has got an address. Therefore, you could quickly jump to various objects properties and go back to some other object. So therefore it's great for rapidly changing data with foreseeable database size. Why? Because if the database size is not good, if it is not fitting into the memory, then then it cannot be handled by Redis. Okay, so the example use cases of Redis are to store real-time stock prices, real-time analytics, leaderboards, real-time communication, and whenever you used memcached before. Have you used memcached earlier? Has anybody used memcached earlier? All right. If you develop a website and you find your website is slow, so what you do is instead of recomputing the data again and again, as we were talking, if you remember our edge-based discussion when we were talking about how to eliminate the bottleneck of the database in the introduction, in those cases we used HBase in case of NoSQL basically when we were talking about NoSQLs. So Memcached is generally used when you want to skip the database lookup and we want to cache some data. So generally Redis could be used for as a caching solution. Okay. Now there is a question. Yes. So Lux is saying that he has used EHCAS. EHCAS is a good solution, I would say. I've used EHCAS earlier, right? Because Lux, probably you are from Java background, and that's the case. All right. So applications like Zookeeper use Redis. Not really, because Zookeeper has their own strategy. Zookeeper has their own store. All right. All right. Now, then what is the point of knowing MongoDB? MongoDB is document-oriented database. And when I say document, what does it mean? Something like this. You see on the right-hand side? This is a document. It has got one attribute called first name, last name, age, address, and phone numbers. Okay? So this is a JSON object or a document. It is best used if you need dynamic queries, if you prefer to define indexes, not MapReduce functions, if you need good performance on a big database. All right. So if you are running a website and you are using MySQL in backend, if your website grows bigger and bigger and your MySQL is being hurt badly every time you have to render the page, you are making hundreds of queries. In all those cases, you could store the page in the form of object in MongoDB, because MongoDB is well distributed database. It has the same concept as Zookeeper, in which there are elections and there is one node which handles the writes, while there are all nodes which can handle the reads. And slicing of the table is similar to HBase, where they keep on slicing the data and dividing it across the cluster. All right. So MongoDB is a document oriented database. So most things that you would do with MySQL or Postgres, but you have predefined columns which are holding you back. The another use case of MongoDB is, since MongoDB does not have a schema constraint, so upgrading the data is fairly easy and simple. All right. Now there is another database called Cassandra. Okay, so it basically stores huge data set in almost SQL. Okay, almost SQL. It provides you SQL kind of query language, which our HBase did not. So whenever you want to store huge data that it doesn't fit on one server, but still want a friendly interface to it, then you can use Cassandra. All right. If you already have Hadoop cluster, you could use HBase. Otherwise, you could go for Cassandra. HBase is also recently performing better than or comparable to Cassandra. Okay. So we can do the web analytics to count hits by hour, by browser, by IP, etc. Why? Because it provides a very easy slicing mechanism. It can slice the tables easily. Okay. Next is for you can use Cassandra for transaction logging, data collections from huge sensor arrays such as IoT. So you can if you have IoT project in place, you could use Cassandra for storing the data collection. Okay. So Lux's question is MongoDB in memory or disk based? Okay, it is both. So let's call it disk based with lot of caching. It caches lot of objects in order to speed up things. even without indexing, sometimes it caches data such as the indexing is automatically there. So basically, MongoDB tries its best to be really fast while retrieving the data. Okay, so that was Cassandra. And HBase we have discussed in detail. So whenever you have to go for really big data, such as billions of rows and millions of columns, then you use Hadoop. Hadoop is probably best way to run MapReduce jobs on huge dataset. Huge when I say it's a web scale. Okay, it's best if you use Hadoop SDFS already. Okay, if you already have this Hadoop SDFS stack, I mean HBase would come naturally. Okay, so search engines could use HBase for storing the corpus, as in text and everything, and it can be used to analyze log data. Any place where scanning huge two dimensional joinless tables are requirements. Okay, because joining HBase tables is like very difficult thing. So similar to HBase, there is something called accumulo makes very big table with cell level security, and hypertable is faster but smaller HBase. Okay, you can see more details about various databases on this website. I found this website really useful. All right, so that's pretty much about about the course, and we will now proceed to understanding the project. All right, so the project which we are going to do is very straightforward and simple. All right, the project which we are going to do is very straightforward and simple. You can either use the same project or you can do the variations. All right, let's open the project. Okay, is everyone with me? This is very important. Great, this is very important for all of us. So the objective of this project is to first do the rudimentary work, which is a very common problem, but there are many variations that are possible. Okay, so the problem statement is the objective of this exercise is to do the sentiment analysis based on tweets data downloaded from Twitter. Okay, so based on the tweets data downloaded from Twitter, you have to analyze the popularity of movie called Iron Man. Okay, or the steps below here, whatever we step we talk about are for analyzing Iron Man using Hive, using very simple strategy. Okay, it's up to you whether you choose exactly same steps or you use different strategy altogether. There are various deviations possible. For example, you could use pig instead of hive, or you could use completely different algorithm to compute the sentiment based, such as NLP, natural language processing. You could use your own Flume pipeline to download the data. Right now we have downloaded the data for you. Okay, or create your own program to download data from Twitter if you don't want to use Flume. Or you could use some other mechanism for displaying the data. Right now, we are trying to display the data inside Excel sheet, but you could use other mechanisms such as D3JS for displaying the charts and the graphics. Okay. Also, there are much more applications to different kinds of applications, different kinds of strategies for doing the sentiment analysis. Some of those are mentioned on this URL. Okay, Now let's talk about this simple strategy which we are going to do. First, log into this. All right. And once you have logged in, let me just try to log in from your account and see. All right. So here is our, do you see here sentiment files? Here is the whole project, whole data of this project. All right. Now locate the data here. I will just change the folder. All right. Let me just copy this and change here. Okay. So under this folder, you will find the data here. This folder contains the data needed for this. One is, this is the tweets, raw tweets in the form of Gunzip. Our Hive will understand this Gunzip data right away. Okay. And for this to run, you will, because this data, if you saw, the data was in JSON format and that too unzipped. To process this data, you would require something called JSON Survey. I have kept the JSON Survey here, as well as the whole SQL query that you need to run is also present here. This is just a sample work. If you want to use this, you use this. Otherwise, you can write your own. Okay, this is just the sample one. If you can, you should find out a better approach than this one. All right. Now follow the Hive DDL. This. Okay. In this, first, you create an external table by parsing the data using the JSON survey. And how does it know about JSON survey? Because at the top, you're going to use this. All right. Now, once that is done, once you have created this external table called tweets underscore row, you also create a table called dictionary, another table called time zone map. Okay. These three tables you create as external. Now based on these tables, you start cleaning up the data. Here we are only picking up ID, date time, and the text along with the time zone. We need time zone because we want to just keep the just we want to figure out the country. All right. Then so this is a view created on this external table called tweets raw. Then we are picking up tweets underscore clean, which is a view created on top of tweets.simple by only picking up these values. And after joining time zone map, okay, after joining time zone map, we are picking up the country. Now we have ID, text, timestamp, and the country in our dataset. Now, once we are done with having these four columns, all we do is tweet, we join the tweets underscore clean. Where is the tweets underscore clean? Okay, select ID words. Okay, so out of tweets underscore raw, we are breaking the text into words, and after that we are joining L1. Okay, we are basically here we are creating in the L2, we are creating the words. All right. Now, so this tweets underscore clean contains the clean tweets. You can actually use tweets clean instead of this. Never mind. So here L3 is being created by joining L1 and the dictionary. Dictionary contains the information about every word. Okay, dictionary contains information about every word, and based on the dictionary, we compute the negative and positive polarity. At a later point of time, we sum up the polarity of all the words in this particular tweet. We are saying group by ID. So we are grouping all the words from a tweet and their sentiments together and computing the sum. In case the sum is greater than 0, we are saying the tweet is positive, otherwise we are saying tweet is negative. Alright? Now, after that, we are putting everything into this tweets BI. We are saying create table tweets BI stored as ORC format, and this is what we are running. Okay, so tweets BI is the final table that we need. These everything else from here onwards you can remove. Okay, we don't need all of this. Okay, we need only up to this. Alright, so once you have done creating this tweets BI, you can access this table from JDBC driver. Okay, in the JDBC driver, the URL is going to be this one, and also either you can include the Hive JDBC driver or you could use some other driver provided by Hortonworks. Okay, here we are trying to present the data in Excel using Excel driver. So you can basically create your install the Excel driver on inside your Microsoft Excel and then follow this particular document on how to install and test the driver. One, while creating the connection, make sure you are connecting to Hadoop 1, Hive Server 2, provide your username and password, whatever has been provided. I think, okay, as mentioned in LMS. Okay, at this particular port. All right, these are the various steps. How would you present this data in Excel? Okay, so you will get the better the it, your project will be considered better if you do it in a little different or a better approach than what is mentioned in this document. The approach in this document is just primary. There are many improvement possible. All right. All right. So have a look at this particular project and it should be clear to you. All right. Good. Good. So that's pretty much we had planned to talk today. If you have any questions, I would like to answer now. All right. There is a question from Sanjay. Question is, how does HBase or any column oriented database resolve many to many and parent-child relationship. Let's not talk about column-oriented database because that's only related to how the data is actually stored. Okay, it has no impact on the data model. Okay, so I would say that HBase or any NoSQL, probably that's what your question is. All right, there are a few more questions. Let stay tuned. There's another question from Savannah. How much time will it take to download data? There are a few more questions. Let me complete. All right. All right. Lux, still, it's not time to thank you. We will talk about thank you in a while. All right. How long is to work on this? All right. And here is another question. Okay, let me try to answer these, and then we'll. All right. So Sanjay has explained his question a little bit more details. Good. All right. All right. Let me take up the questions one by one, and then we will have a thank you note session. Good. So here is a very good question from Sanjay. Question is, when we have these HBase or NoSQLs where you have no foreign key relationships and parent-child relationships, how do we handle such kind of scenario? How does master data like customer address designed in a column family, which are commonly referenced in say two tables, column order and purchase order, customer order and purchase order, is it duplicated across column families like customer address column family 1, customer address column family 2? Okay, let me think about this problem again. So let's say there is a customer address designed in. How does master data like customer address designed in a column family which are commonly referenced in, say, two tables, customer order and purchase order? Is it duplicated across cust okay, so what you are saying is there is something called customer information like customer address, and that customer address need to be referred in both customer order as well as purchase order, right? So generally in these cases what you do is you basically define a single column family for customer details, and then customer details is one column family which contains address, name and whatnot, and then you have all the parameters of order for that particular customer. Okay, let me try to explain again. Imagine this. You have a column family called customer data, all of the data. So it has row key called customer email ID. Okay, and one column family is customer data CF. Okay, and another column family is say order details CF, and third column family is say purchase order CF. Okay, under under this there will be multiple columns like name, address, uh, I mean what do you call billing address, or and then residential address, residential address, or shipping address. Okay, shipping address, name, etc. Then you have, under the second column family, you have order details. Under order details you have order ID, and you have say say item and since we can have the item ID, item 1, item 2 in the column name, item 3, okay, so on, okay, in the column name. Remember that these are the column name. If you have multiple orders for a customer, you can have multiple items in the column name. And then in the value, here in the value, you could have the details about order, details about item, how many quantities, etc. So although this design looks little awkward, but when you have to scale, you don't have a choice. Does it make sense, Sanjay, now? All right, great. Similarly, in case of purchase order, you could have these column family. Under this column family, you could have names like purchase order 1, purchase order 2, purchase order 3, and in the value could be value could be the binary scanned copy of purchase order. Okay, so generally you can model most of the things in this manner. One to many relationships in case of HBase are easier by adding more and more columns as we are adding data into the table. Yes, so here customer data row key is the key here. Row key is the key. Customer email ID, what we have done. So data togetherness is important. That's correct. Now I got your point. Yes. All right. Because it's not possible when you have mammoth tables, it's not possible to join the tables. Generally, also please all of you keep in mind, generally designing an application requires both kind of databases. So it's okay to go with a hybrid kind of approach. All right. All right, let's take few more questions. How much time it will take to download tweets data using Flume? I would say, um, I would say it might take quite a bit of time. Uh, just it would mainly depend on your bandwidth, okay, and how much sample data are you trying to download, okay. I don't have exact numbers. How long is the time to work on project? Okay, I'll answer to this one. So go to your project here. At the top, you will see the end date has to be slided one. Yeah, end date is correct. So project start date is today. Okay, and last date for the assignments is next week, while project's submission date is 1 week later than this. Okay, 1 week later than this. All right. We will update the project submission date. Project submission date is generally 1 week later than the assignment date. All right. So you generally have like 2 weeks to finish the project. There are multiple sources of setups like Hortonworks, Cloudera, Apache. Which one is better? We prefer the Hortonworks. Hortonworks. All right. All right. So that was pretty much from our side. I hope you enjoyed the session. And let me just unmute you if you have to say something. All right. So, all right. Anandita, will it be okay to unmute you? Jairam, will it be okay to unmute you? Joshi, will that be okay to unmute you? Please let me know if you want to be unmuted. All right. And all right. All right. So Savna's question is that after doing the project, is there a possibilities to get more project? Yes, definitely yes. So for example, one of our students who has done really good work, so I have put him with people from Dell in fixing in basically establishing their order management analytics. Okay, so they have around 45 million events every day that need to be handled. Okay, so for that they needed some help from me. I was not getting enough time, so one of my student who was very excited about it is taking care of that. All right, so lot of consulting project keep coming to me, and I generally redirect those to my students, provided they have shown some sincerity in getting the assignments and the projects done, because that's the only way I have to evaluate you. All right. So generally most of the consulting work I'm not touching. So I